Okay, so good morning, one and all. The recording has been started. So we will do today the experiment called as the impulse response and step response of given transfer function. So we have come to know about the transfer function. So there are two methods of transfer function finding we have learnt. One is the block. Uh, Okay, so we have been processing the block diagram. So it's called as block reduction method. That is the first process, and second process is called as signal flow graph. So though we don't know the things fully, but yes, the basic things we know about block reduction as well as the signal flow graph. So what after finding the block diagrams or after finding the transfer function, then what? So finding transfer function is not the main thing, but yes, without transfer function also we cannot do anything. So how to use the transfer function? That is the question now. Now I have shared my screen. So this is going to be lab 4. So exactly this is not a direct. So if you see the list of experiments that you are supposed to perform, this is not exactly the thing which is mentioned there, but I will bring it to something like as finding the transfer function, finding the system response when pole positions are given. So something like that is given in your list of experiments, that is finding the roots of the denominator or finding the roots of characteristic equation, and then from there finding the stability of it. So all those things are there in some experiment. I think it is experiment number 6 or something. So what we are going to do is, so this is going to be a lab number 4, and lab number 4 title is given. So a request to all of you is whatever the way, exactly the way I have designed the front page before experiment 1, it was sent to you exactly the way it is to be defined, it is to be designed. Exactly the same way you design the cover page for all the experiments. Okay, and there write this title. So title is given already, lab 4 pole position and impulse and step response for closed loop system. So this is just a name, and what all we have to do, that we will see. So not only we will stick to closed loop system or impulse or step response, but also we will find out for a given transfer function what is the where are the poles, and what is the time domain response. So there are two things. First one is, so if you are having pen and paper, you can write these things down. So I told you that always have pen and paper and have calci also. So today we might require calculator. So pen, paper, calculator, all this thing you should be having while attending the lecture as well as lab. So few things we have to write down. That is, first is what all things we are finding actually. So first we are finding the transfer function. So what is given? So let us start from given thing. So given will be GS and HS. Okay, so those who are writing, you can write down. So it is exactly in the same way. So say the forward system gain GS is 1 by S plus 4. Anybody can confirm that if my note is visible to you, if this
Yes,
page that is displayed is given to you.
Yes, sir.
So in this I have written here the title, and say forward system gain GS equal to 1 by S plus 4. So numerical, whenever asked in exam, then also GS and HS should be given to you. If HS is not given, then what? So sometimes HS, which is the feedback gain, might not be given. If it is not given, assume that to be 1. So now we are entering actual control system. So far I had been conditioning you. So far I had been telling you something is given, how to do that. Okay, but how to do what? Okay, that is how to correlate all these methods that we are learning with the system analysis. So now we are going in the system analysis part. Whatever things we have learned in previous 3 experiments, as well as in block reduction, signal flow and all, so they are nothing but the mathematical steps. How to use those mathematical steps to design the system stability, or to design a proper system, or to know the system response better. Now we are actually entering the control system domain. We are trying to find out what is the system response. If impulse is given as the input, if step is given as the input, if you know this, Now then I can ask you, find what will be the system output. If ramp is given as the input, you will be able to find out. So I'm just we are just entering the field of control system now. So say the forward system gain is given gs 1 by s plus 4. Okay, so 1 by s plus 4, so it will be, everything will be given in a Laplace domain. And suppose feedback gain is not given, hs is not mentioned. Okay, so here I forgot to mention hs. Feedback gain we are calling as hs. Okay, so hs equal to 1. What is meant by feedback gain is equal to 1? So feedback gain is equal to 1 is called as a unity feedback system. So keep writing all these things. Unity feedback system. Unity feedback system is CS. Nothing is going at the output. Whatever signal we are generating, all the signal is being fed back to the input. Generally, whenever we are taking a feedback, how much percent of the output we are taking as feedback? Hardly 5% or hardly 7% or maximum 10%. Example, we go to a sweet shop to buy a sweet. I want to buy 1 kg of peda. I tell them that test karao. Test karao means they just give one bite of it and we taste it, and we buy 1 kg of peda and bring it home. So do we test 1 kg for testing? So testing is nothing but the feedback. Okay, so we want to buy 1 kg of kaju katli or 1 kg of peda, and we want to just have a feedback before purchase. Before purchase only you can have a feedback, then only you can do good purchase. So तुम थोड़ा सा खाते हो, खा के अच्छा लगता है, हाँ ठीक है, this is not bad, this is good quality, and then you purchase. But what happens कि तुम बोलते हो कि I want to feedback, I want to test, and तुम 1 kg खा ही जाते हो. It doesn't happen. But in this case, that thing is happening. That is feedback n is equal to 1. Feedback n is equal to 1 means, why do we take feedback? That is the first thing. We take feedback. So we are taking students' feedback. So after I complete the course, I will take feedback from you people. That how was my teaching? Where all did I go wrong? Okay, how could I improve my teaching? So always take the feedback, and you can give your feedback without any kind of hesitation. Feedback should be taken for improvement of the system. So some students, if they say, sir aap ye unit acha nahi padhaye, wo usme ye galat tha, ye all those things, I should take it in a positive sense. I should not think that he is trying to unnecessarily trouble me. Okay, so that is negative feedback. Negative feedback actually makes the system more stable. That is what it is. So if you find out some proper real problem that I had created to you, okay, or some real negative thing that I could improve upon, if you tell me that, so that should be proper. Okay, in that case it will add to my teaching. My teaching will become better. So what we are saying is, in that case, feedback is 100%. Feedback is 100% means that sweet example is the best thing. That is, I go to purchase 1 kg of sweet, and 1 kg में feedback के नाम पे खा जाता हूँ, testing के नाम पे खा जाता हूँ. तो घर में क्या लाओगे? कुछ नहीं. Exactly the same thing happens here. If all the outputs are taken and brought back to the input, okay, output is CS, the whole CS is brought back to the input, then it is called as 100% feedback. H is equal to 1. Sometimes it happens, but generally we take hardly 10%. So generally the HS value ideally is 0.05. 0.05 means 5%, or HS value sometimes is 0.1. 0.1 means 10%. Okay, so 0.1 feedback itself is very big thing. That means 10% is taken back and 90% goes to the output likewise. So type of the feedback, obviously type of the feedback is negative, because negative feedback is actually making the system stable. Now there are two transfer functions. So everything I tell you, I will upload this note afterwards, but before reading the note, you should listen to what all I am saying, because a lot of things will be discussed which is not there written here. But yes, listen to the session and then read the notes. You will understand the very basic concept which is not written this way in any book. Okay, a lot of things are written in books about stability and all, but what I am showing you is a gist of it. Okay, so open loop transfer function. So there are two transfer functions. One is called as OLTF, one is called as CLTF. So OLTF is nothing but GS into HS. What is the exact significance, physical significance? आज नहीं बताएंगे. We will find it out during we are doing root locus in the 4th chapter, or maybe 3rd chapter, or maybe some time in the lecture I will tell you. But just know this much, I told you already previously, GS into HS. Forward gain is GS in this case is given by 1 by s plus 4, so some function will be given to you. HS can be again another function, so HS can be s, HS can be 1 by s plus 2. So they are all function of s because we are actually finding the transfer function in Laplace domain. So GS is 1 by s plus 4. HS can be here feedback gain equal to 1. In this case, I have taken it's called as unity feedback. In exam, if HS is not given in exam, if they say only forward gain, so this same thing will happen in a lot of numericals also that will be solving. Only GS is given, HS is not given. If HS is not given, you take HS equal to 1. And whatever things you are assuming in the exam, write it very clearly that I am assuming the system to be unity feedback system. Unity feedback means whatever is being generated at the output, everything is being taken back and given to the input. Okay, so the system is the same. That is, left side there is the RS, that is the set point input. Then you are taking the feedback from CS, it is getting multiplied with HS. So BS is equal to CS into HS, and we are generating error signal. So error signal is equal to RS, that is the set point minus BS. So set point minus feedback. So ES is equal to RS minus BS. Same thing here. Only thing is H is equal to 1 we are taking. So BS is equal to CS. That means whatever is the BS, that is feedback signal, that is equal to CS. So 100% is taken at the input. Okay, now what we are finding is what is OLTF, open loop transfer function. Just multiply GS and HS. So GS is 1 by s plus 4, H is equal to 1. So OLTF, open loop transfer function, or sometimes it is called as loop transfer function also, it is 1 by s plus 4. This is not having any physical significance in control system, but yes, while calculation, while analyzing, this is having some significance because one thing you know from here, that just looking at the open loop transfer function, I shall be able to predict what is going to be the stability of the closed loop system. So below I have written a closed loop system. What is closed loop system transfer function? TS, it is equal to GS by 1 plus GSHS. So now H is equal to 1, so this is going to be GS by 1 plus GS. So TS, that is the closed loop transfer function, which is also called as CLTF. So two new terms I'm introducing. One is called as open loop transfer function, and another is called as closed loop transfer function. So if anybody is having any doubt, please ask me. Write or unmute yourself and ask. Any kind of doubt, don't hesitate. Okay, so open loop transfer function is GS into HS. It's having its analytical significance, not a direct physical significance. And a closed loop transfer function is GS by 1 plus GSHS. Now I have given you GS is equal to 1 by S plus 4, a very simple system I have taken, because my main aim is to find what is the impulse response, that is the first thing, what is meant by step response, second thing, and to understand the concept of stability and pole position. So these are four agendas today. First is impulse response, second is what is meant by pole position in Laplace domain, third is concept of stability, and finally we will see what is the step response. Okay, so for this closed loop transfer function, we will find out all this. That is impulse response, step response, then stability, and then what is the pole position. All these things we will be finding. So CLTF is equal to GS. So GS is given as 1 by S plus 4 and 1 plus GS into HS. Okay. So the same thing will be asked in numerical also. Okay. So everything I'm teaching is applicable everywhere. So don't think lab is different, theory is different. No, whatever I'm teaching in the lab, same concepts will be used in the theory. So again, I will not explain you how to find transfer function, how to find impulse response. I will not teach you in the theory because the same topic is there, I think, as a case study or as a self preparation topic in module 2. That is what is impulse response, step response and all. So I will not be explaining it there. I will not be wasting my time. It is being done in lab only. So GS 1 by S plus 4, 1 plus GS into HS. So HS, if not given, you can take as 1. If you solve this, it will be 1 by s plus 4. Denominator will be s plus 4 plus 1 divided by s plus 4. Now denominator both case s plus 4 cancel that. So transfer function becomes 1 by s plus 5. So GS is 1 by s plus 4. H is equal to 1. What is closed loop transfer function? 1 by s plus 5. Is it understandable by all of you? Just one or two of you just say yes. How to find closed loop transfer function from GS and HS? If you have understood, you can say yes, or you can just write yes in the chat box so that I can go forward. And how to find the characteristic equation? So TF, this is Okay, Ashutosh has said, Mohit has said, Chinmay. Thank you, thank you. So you're following. So thanks to you, it is not difficult. Okay, so it is not difficult. Only I waste much time to explain this because I go slow and I tell a lot of things. Okay, so these are very simple things. A lot of people might be feeling that sir, क्या इतना बता रहे हो, bore हो रहा है. But ठीक है, anyways, let us go slow. Okay, so closed loop transfer function is GS by 1 plus GSHS. GS is forward path gain, HS is feedback gain, and HS also can be a function of S. So HS also can be 1 by S plus 3 possible. So I can give HS as 1 by S plus 3, GS as 1 by S plus 4, and I can ask you find what is TS, find what is the pole position, find what is the impulse response, step response. So many numericals, thousands of numericals can be designed on this. Okay. Likewise. So what we find is closed loop transfer function Ts is equal to 1 by S plus 5. This is what we have found. Now I told you one thing. What is meant by characteristic equation? Okay, so this is also a topic of your syllabus module 2. Okay, so module 2, the third part. So first part reduction technique. Second part is signal flow graph, and the third part of module 2. So first thing is topic is characteristic equation, then there is pole position, and then there is impulse and step response, which is the added topic. So all these things I'm doing here because actually I'm doing syllabus more than the lab. Now, what is meant by characteristic equation? So whatever numerator equation, so numerator also can be a polynomial of S, depends on what is the GS and HS given. So very simple GS I have taken, so numerator is 1, but not every time numerator will be 1. So numerator will be a polynomial in S, denominator also will be a polynomial in S. So now whatever denominator polynomial I'm finding S plus 5, so it's a first order system. Again, another important thing. GSHS, whatever you are finding, it is 1 by S plus 4. Okay, so from here, just know this much at present I'm telling you, I'll not explain now. From open loop transfer function GSHS, you can write down in your notebook, we can find out type. What is the type of the system? Okay, so what is the type of the system? Here, it's a type 0 system. Why, I will tell you later. So just write down that from OLTF, that is from GS into HS, I can find what is the type of the system. Okay, so it's a type 0 system. What is type? I will explain to you some other day during theory class. So it's a type 0 system. So GSHS 1 by S plus 4, it's a type 0 system. And from closed loop transfer function denominator equation, that is S plus 5, what is the power of S? Power of S is equal to 1. So it's a first order system. So whatever system we are thinking about or talking about, it may be a resistor, capacitor, inductor kind of a circuit. So either it is RL circuit or it can be RC circuit. It cannot be a RLC circuit because RLC circuit is a second order system. Second order system will be having S square plus something of S plus constant. But here we are finding only S plus 5. That means it can be a RC circuit. Okay, or it can be a RL circuit. So it's a first order system. That means there is only one energy storing element in this. So either it can be RL or it can be RC. It cannot be RLC or it cannot be LC because LC circuit is also a second order system. RLC circuit is also a second order system. So what is the characteristic equation? S plus 5 is equal to 0. So definition of characteristic equation is, I'm telling you, if you want, you can write down, that is whatever is the uh, closed loop transfer function, denominator of that equal to 0. That is actually the system characteristic equation. And what do we find from this characteristic equation? We can find the values of S for which this equation is going to have 0. That means we are actually finding the roots of this equation. So roots of characteristic equation S is equal to minus 5 is called as a pole. Okay, so closed loop transfer function TS GS by 1 plus GSHS. From there you are finding what is the CLTF. Whatever is the numerator polynomial, if you solve that, whatever values you get, it's called the zeros. Okay, so now today I will be posting another two numericals. Characteristic equation 1 by S plus 5. So S plus 5 is equal to 0 is characteristic equation. Whatever is the denominator of a closed loop transfer function, that equal to 0. That is called as characteristic equation, because characteristic equation, if we solve, as here you are finding 1 by S plus 5. So S plus 5 is equal to 0 is the characteristic equation. That is the denominator equation of closed loop transfer function. That is actually characteristic equation. And that equation, if we are solving, we are finding poles, and poles are actually important for analyzing the system stability. Asutosh, is it okay? Just say yes or no, I'll explain again. Denominator of closed loop transfer function, here you are finding it s plus 5, that equal to 0. Difference between first order and second order, here the characteristic equation is s plus 5, so order of s is 1, it's a first order system. If the characteristic equation was s square plus 3s plus 2, then the order of s was maximum 2, so in that case it would have been a second order system. Okay, so whatever is the highest power of s in the characteristic equation, that is actually the order of system. Okay, so in this case 1 by s plus 5, so s raised to 1, that means it's a first order system. If it was 1 by s square plus 3s plus 2 or 1 by s square plus 7s plus 19, that was equal to 0. So in that case you have to solve a quadratic equation. Okay, s square plus 7s plus 19. If this was a denominator equation, then we could have called that system is a second order system. Ethersam, understood? Please respond. Okay, so what is the significance of second order system, that you could ask me? What is meant by first order system? First order system is there is only one energy storing element. So either it can be RC circuit or RL circuit, 1 by s plus 5. I don't know which one. Okay, but there is only one energy storing element in first order system. But if it was second order circuit, 1 by s square plus 3s plus 5, that means characteristic equation is s square plus 3s plus 5 is equal to 0. In that case, that would have been a second order system. That means there are two energy storing elements. Okay, so number of energy storing element is equal to the order of the system. Okay, that is what it is. So in this case, characteristic equation s plus 5 is equal to 0. If you are solving it, you are finding s is equal to minus 5. So up till this, I think we are done. Plot it here. Okay, so Laplace domain pole. So this is called as Laplace domain. So this is sigma axis, that is the real axis, and this is the j omega axis. So in this case, this is the left hand side of S plane. This is the right hand side of S plane. Plotted here, S is equal to minus 5. So it is. So this is S plane. S is sigma plus j omega. This is called complex frequency. This is the Laplace transform, and this is how the complex number looks like. Now, many of you just concentrate. If I say 2 plus j3, okay, how does it look? 2 plus j3 in this S plane. So in this case, you have to plot here. This is 2 plus 2, and j3 will be here. So here you have to put a cross, and this is called as 2 plus j3. If I say minus 5 plus j7, so this is minus 5, and j7 is up here in the second quadrant. Here you have to put a cross. Cross means pole position. Okay, so pole is given by a cross symbol. 0 is given by a round. So in this case, minus 2 plus minus 5 plus j7, if I say. So this is minus 5, and up you have to go plus j7. So y-axis is given by j omega. And omega is nothing but radian per second. That is nothing but frequency. And this real frequency, and that is j omega, is the imaginary frequency. So it's called S is called as a complex frequency. So S Laplace, the operator, is equal to sigma plus j omega. So the Laplace operator is having two parts, real and imaginary, and this is how the S is presented. So in this case, I am finding S plus 5 is equal to 0, S is equal to minus 5. So plot this minus 5 here. Okay, so this is S is equal to minus 5. If there was a 0, suppose numerator was suppose S plus 7. Okay, S plus 7, this was the numerator. Just take an example. Numerator was S plus 7, that means S is equal to minus 7. That is not characteristic equation, that is numerator equation. Characteristic equation is given from the denominator. So if there was a S plus 7, S is equal to minus 7 was a 0. So in this case here you had to just put a round. Here you have to put a round, and you have to say that this is minus 7. Okay, so for stability of the system, we try to find out what is the position of pole in case of what is the position of pole in case of any system. Okay, so we will discuss about that, but before that, let us go for what is meant by impulse response. So in this case, the pole is real, okay, because the pole is only minus 5. It is not minus 5 plus j2 or minus 5 minus j2 something. So pole can have both parts, real part as well as imaginary part. In this case, we are finding that pole is having only real part. That is minus 5. Okay, so it's called a real pole. Sometimes system might have a imaginary pole. Suppose you are having denominator equation as s square plus 7s plus 39. In that case, if you find the pole positions and all, you will be finding minus 2 plus minus 3j. Suppose. Okay, so this s is equal to minus 2 plus 3j and minus 2 minus 3j. So in this case, one pole will be above here, another pole will be down here. So whenever you are finding complex poles will always be in a conjugate form. So minus 2 plus J3, if it is there, minus 2 minus J3 will also be there. So here it's a real pole, so there is no problem. And the pole of the real and pole lies in the left hand side of S plane and system is stable. How? This I will explain now. Okay, but before that, just find what is meant by impulse response of the closed loop system. So now I given you GS, I given you HS. You found out transfer function, that is closed loop transfer function. Same thing will have to be repeated everywhere. So tonight again I'm going to ask you another homework question, small question, and again you have to answer and upload. So just I'll give you some function. You have to find closed loop pole, closed loop zeros. You have to plot this in real axis, imaginary axis, and you have to upload it. So just for a practice, one numerical I will upload. So TS, now what is TS? TS is the transfer function we have found here, 1 by S plus 5. So TS is equal to output by input. Now you concentrate, because if you go and try to find this thing in the book, you don't know how to search, where to search, and very big things you have to search. After that you will come to this point, but very simple things you will come to know from this lecture. So TS is equal to ys by xs, that is output Laplace divided by input Laplace, is equal to 1 by S plus 5. So what is ys? Ys is the Laplace of output, xs is the Laplace of input. So do the cross multiplication here. Now concentrate, all of you, I want your concentration. So ys is equal to xs into 1 by S plus 5. What is 1 by S plus 5? This is the TS. TS is nothing but the transfer function. So what is YS? YS is the output. Okay, so now I'm trying to tell you what is meant by impulse response. So YS is equal to XS into 1 by S plus 5. So what is YS is equal to XS? Now if it is impulse response, that means you have to input the system with impulse input. So what is impulse input? Impulse input is delta T. What is the Laplace transform of that? Laplace transform of impulse is 1. So in that case, we are finding out YS. That means we are trying to find out output when input is impulse. So that's why instead of XS, I have substituted the Laplace transform of delta T. And Laplace transform of delta T is equal to 1. Okay. If it was a step response, I had to substitute XS, that is the Laplace transform of UT. What is meant by UT? Amplitude of UT is 1. UT is nothing but unit step. What is the Laplace transform of 1? It was 1 by S. So in that case, if I am asking you, find the step response. In that case, you have to substitute, instead of 1, you have to substitute XS as 1 by S. And then find what is YS. So very important point, I am repeating once again. TS, I know 1 by S plus 5. I am asking you to find impulse response of the system. Okay, in time domain. So all these things are in frequency domain, that is complex frequency or Laplace domain, but I have to find time domain impulse response. So for that, first I should know Laplace domain impulse response. So how to find Laplace domain impulse response? So ys by xs is 1 by S plus 5. We have found it out. So what is ys? Ys is equal to xs into 1 by S plus 5, where xs is the Laplace transform of the input. Now what input I'm giving? I'm asking you to find out impulse response, means xs you substitute as Laplace transform of delta t, and Laplace transform delta t is equal to 1. So substitute xs as 1. So ys you are finding as 1 into 1 by S plus 5 is equal to 1 by S plus 5. So if you are having pen and paper, just write down one thing, that impulse response of a system is equal to transfer function. That is, you write impulse response of a system is equal to its transfer function. Why? Because transfer function is ys by xs and impulse response is ys. So ts is equal to ys because xs is equal to 1. Okay, so ts is equal to ys equal to 1 by S plus 5 because xs is equal to 1. What is xs? Xs is nothing but the impulse response Laplace transform. Now impulse signal is given by delta t. If you are converting that thing into Laplace domain, you are getting 1. So substitute xs is equal to 1. So when xs is equal to 1, we find transfer function is equal to output response. So ts is equal to ys if xs is equal to 1, and when xs is equal to 1, if the input is impulse, then xs is equal to 1. So this is a very important thing in communication, that is find the system impulse response. What is meant by find the system impulse response? Whatever is the transfer function, that is actually the impulse response of the system. Whatever is t of t, that is transfer function in time domain, that is same as y of t. Okay, so you know now 1 by s plus 5 is equal to ys. So ys is equal to ts equal to 1 by s plus 5 because xs is equal to 1. Okay, so what is the significance of impulse response? Significance of impulse response is it is same as transfer function. So what is the impulse response of impulse response significance? It is same as transfer function because input is equal to 1. For step response, you cannot say like that. If it was step response, ys would have been 1 by s into 1 by s plus 5. Okay, so what is step response? Step response is equal to transfer function divided by s. What is step response? Again, you write down transfer function divided by s because in that case, ys would have been 1 by s into 1 by s plus 5. Okay, so whatever is the transfer function, that is ts divided by s, that is actually is called step response of the system. So impulse response is equal to ts and step response is equal to ts by s. Okay, from there you have to go to yt. Now how can you find yt from ys? You have to take what is called as inverse Laplace transform ILT. So closed loop impulse response is given by system. Now given as GSHS, you are finding ys is equal to 1 by s plus 5. Take inverse Laplace transform. Now we are going slowly towards definition of uh, stability. Okay, so first I have given you GS, I have given you HS. From there you have found out what is called as TS, that is the closed loop transfer function CLTF. From CLTF you found out what is the characteristic equation, that is the denominator s plus 5 is equal to 0. You have solved it. After solving the characteristic equation you have found out what is the pole. Now pole is in the left hand side of the S plane, so we know that if the pole is in the left hand side of S plane, system is stable. But how? Pole left hand side mein hai to system stable hai, so there is a gap in between that, so that gap I will close now. Okay, so ys is equal to 1 by s plus 5, that is same as ts because xs is equal to 1. All these things we have known so far. Now take the inverse Laplace transform. So ys is equal to 1 by s plus 5, so yt is equal to e raised to minus 5t. We all know this because we have done Laplace transform in first year, second year network analysis. Yt is equal to e raised to minus 5t. So this is an exponentially decreasing graph. It is shown here. Okay, so yt is equal to e raised to minus 5t. This is called a time domain closed loop impulse response. Okay, so whenever I am asking you to find a response, the response you have to find in time domain. So there can be two types of response. I ask you, so I give you a transfer function that is ys by xs. I ask you to find out impulse response number one. I ask you to find out step response number two. So this is our lab today. Okay, for any given transfer function, closed loop transfer function, we can find out and we can plot. So we know what is the plot command in MATLAB. We can find out what is the impulse response plot. How does the impulse response look like in time domain? That means if you are giving the impulse as the input, how will be the system output in time domain? Or if you are giving the step input, that means unit step input as the input, how will the output look like in time domain? So response is always found in time domain. Those things we are going to find out today in MATLAB session. So today we have found out that ys equal to 1 by s plus 5 because xs is equal to 1. Take the inverse Laplace, yt is equal to e raised to minus 5t. This is called a time domain closed loop impulse response. Very important thing. This is called a time domain closed loop impulse response. Time domain means I have taken the inverse Laplace, that's why time domain. Closed loop means I have found out ts first. Ts equal to ys by xs. Ts is closed loop transfer function, that is gs by 1 plus gshs. There I have substituted xs is equal to 1 and hence I have found out that yt is equal to e raised to minus 5t. So this is called as time domain closed loop impulse response of the system. Now observe, for impulse response ts equal to ys because xs is equal to 1. So ts equal to ys by xs, as xs is equal to 1, ts equal to ys. Why am I telling you all this thing? Because it is my experience which tells me it's a very simple thing, but student cannot understand it because in no book it is written as clearly. It's a very simple fundamental that ts is equal to ys by xs. Xs is nothing but Laplace of impulse. Xs is equal to 1. So if impulse is given at that time, transfer function is equal to output. Whatever is the response of the system, that is nothing but equal to transfer function. So as xs is equal to 1, delta t is equal to 1, Laplace transform it is written here, we find that ts equal to ys and xs is equal to 1. In that case, yt is equal to e raised to minus 5t. Very important thing, how to plot yt is equal to e raised to minus 5t. So if you are doing it in MATLAB will plot it on its own. How can you find, substitute t is equal to 0. So if you are substituting t is equal to 0, you find e raised to minus 5 into 0, e raised to 0 is equal to 1, like this. Okay, then substitute t is equal to 1. So if you want shorter or closer samples, you can substitute t is equal to zero point 0.5, e raised to minus zero point 0.5. Here I have substituted t is equal to 1. That means e raised to minus 5 into 1. That is e raised to minus 5. So it will be somewhere here, very small value. Then at 10 seconds, okay, so substitute for different values of t. So here at 10 seconds, 10 seconds means e raised to minus 50, that will be almost equal to 0. E raised to minus 50 is a very small number, that will be almost equal to 0. Now see this graph. Okay, so now I'll enlarge this graph and just see what all things I can talk about this graph. Okay, what all things. So this is a graph. Very important thing. This is a graph for e raised to minus 5t or e raised to minus 80, you can say. Okay, if it was e raised to minus 2t, the graph would have been flatter like this, but then also it would have come and touched 0 at some point. This is e raised to minus 5t like this. E raised to minus 10t, it would have been come to 0 very sharp. Okay, so we have seen that graph in previous day. That is, smaller is the time constant, smaller is the value of rt, then it will be faster. Okay, so in that case we have seen that e raised to minus 10t will be falling very fast. E raised to minus 5t is this. E raised to minus 3t will be little flatter. E raised to minus 2t will be flatter. Okay, so flatter means it will touch to the ground at later instant, but it has to touch to the ground because e raised to minus infinity is 0. If you are substituting t is equal to minus infinity, that means e raised to minus infinity is equal to 0. That means all the graphs e raised to minus 80, they have to touch the ground or time axis at t is equal to infinity. Hence, this graph e raised to minus 80 and this time axis, they are called as asymptotic. What is meant by asymptotic? So you might have heard many times what is meant by two things are. So if asymptotic means two things can be asymptotic. Rail lines are not asymptotic because wherever you go, rail lines will always go in parallel. So rail lines are not asymptotic. They might look asymptotic. So if you are standing at some place and if you are looking at the rail line, it seems that very दूर जाके वो दोनों एक हो गए. But rail lines are always asymptotic. They are never asymptotic. Okay, in actual field. But this graph e raised to minus 80 and x-axis, they are asymptotic. Asymptotic means, those who are having pen and paper, you can write down. Asymptotic means they touch each other at t is equal to infinity. So in this case, they are touching each other, e raised to minus 5t and this x-axis equation is y is equal to 0. So this y is equal to 0 line or yt is equal to 0 line and e raised to minus 80. So it can be anything. It can be 5, 7, 9, anything. So e raised to minus 80 and yt, they are called as asymptotic because they are touching each other at t is equal to infinity. Okay, hence this is asymptotic curve. If this is an asymptotic curve, then what? Okay, so I told you that s is equal to minus 5. That means this is e raised to minus 5t. In that case, this asymptotic curve, y-axis and x-axis, they are producing a closed area. Now we have started explaining what is the concept of stability. Okay, e raised to minus 5t, if this is the response of a system, this system is a stable system. Why? This is the question. How do you get e raised to minus 5t? Because you are finding 1 by s plus 5 as the transfer function or as the impulse response. So e raised to minus 5t is the impulse response of a system, or 1 by s plus 5 is a transfer function of a system. So e raised to minus 5t, if this is the response of a system, this is a stable response. A system is a stable function. Why? Because this e raised to minus 5t, this x-axis and this y-axis, whatever area they are producing under them, so this hatched portion, okay, this colored portion, this part, this is a closed area. So whenever a system response is producing a closed area with respect to y-axis and x-axis, that system is going to be a stable system. This is the concept of stability. So the system is having an output equation. You just plot that equation. So here the output equation, yt is equal to e raised to minus 5t. So from impulse response, actually we try to find out what is the response of a system in time domain. And if we find that the response of a system is producing a closed area with respect to the x-axis, y-axis and the system curve. If this area is a closed area, then we can say that the energy under the curve, so this area, in if you can find out this much joule, is actually the energy produced by the system. Okay, so this energy produced by the system is equal to area under the curve or area under the impulse response curve. If this area is finite, then the system is called as a stable system. Which system? 1 by s plus 5. So here Ts is equal to 1 by s plus 5. From there we have substituted x is equal to 1. We have found out yt is equal to e raised to minus 5t. E raised to minus 5t we have plotted. We have seen that at t is equal to 0 it starts from 1. At t is equal to infinity it touches at 0. So this is actually t is equal to infinity point, let's assume. And we are finding that this curve e raised to minus 5t or e raised to minus 80, x-axis time domain, y-axis yt, they are producing a bounded area. Another important thing, another important word I have used, it's producing a bounded area. What is meant by bounded area? Bounded area is nothing but this area is finite. You can calculate how much is this area. That is nothing but the energy content in this signal. So if a system or if its response is producing a bounded area, or if a system is producing a finite energy, then that is called as a bounded output. In that case, system is called as a stable system. I will show you how does a unstable system looks like. So first, let us understand whatever system we have defined, that is 1 by s plus 5, that is a TS. E raised to minus 5t curve is called as asymptotic with respect to the time axis, that is the x-axis, as e raised to minus 5t touches the x-axis at t is equal to infinity, because it is asymptotic, as e raised to minus infinity is equal to 0. So when at t is equal to infinity at complete steady state, so as you are reaching to t is equal to infinity, that is called a steady state. The response yt touches the x-axis, hence yt is called as asymptotic graph. Why stable? Very important question. The area between y-axis, that is yt graph, x-axis, that is the time graph, and e raised to minus 5t. So between these three, so if you want the area, you want actually three things. Okay, one is a curve, one is y-axis, one is x-axis. Between them, whatever is the area, that area is finite in this case, because you can calculate how much is the area. So the area between y-axis, x-axis, and the system response, that is e raised to minus 5t. Okay, that is actually a closed area, which means that energy in the yt signal is finite or bounded. What is the input? Input is impulse, bounded input. What is the system output? Output is bounded area. So that's why this is called as a bounded output for a bounded input. So Bibo stability, it is called as Bibo stability. What is meant by Bibo stability? Whenever I am giving a input, that is bounded input. What is meant by bounded? Impulse. Impulse ऐसा नहीं है कि पूरा फैला हुआ है. Impulse is happening for a very small period of time and it is having a constant amplitude. So छोटा सा है. Okay, so it is, you can find out how much is the energy, how much is the area, all those things for an impulse you can find out. So it's a bounded input. If I say triangular waveform, not triangular and going up to infinity, not that, just only this much. Okay, only this much, or a small pulse you are giving. Okay, base is 2, height is 3. So how much is the energy? 2 into 3, 6. Area under the curve is energy. So if I'm giving a bounded input to a system, and if the system is producing a bounded output, in that case, we can call that system as a stable system, because it is producing a bounded output for a bounded input. If I give a bounded input to a system and system is producing unbounded output, I will show you in the next page. The area under that curve is infinite. As time is increasing, the area under the curve is increasing. In that case, we call it unbounded output. So unbounded output for bounded input. In that case, system will be unstable. Why this system is stable? The area between y-axis, x-axis, and the e raised to minus 5t curve is a closed area, which means that energy under the yt curve, that is e raised to minus 5t curve, is finite or bounded. Bounded energy means stable system. So this is now why if the pole is in the left side, then only it is going to be e raised to minus 5t or e raised to minus 80, and if it is e raised to minus 80, then the system is going to produce a curve which is going to have area under curve as finite or bounded. So this is called bounded energy, or this is called bounded curve. Hence the system is going to be called as a stable system. Next, let us see the next page. So it's a 4-page notes. I have completed 2 pages. There are other cases for another system, not for this system. So this system analysis is over. Now we are going to discuss some other systems for instability, marginal stability and all those things. Other example for another system, let's assume that yt is equal to t. Okay, so transfer function we find ys is equal to 1 by s. Okay, or 1 by s square. I'm sorry, ys is equal to 1 by s square. Take the inverse Laplace and you are finding yt is equal to t. This is actually the impulse response of a system. How does the yt is equal to t looks like? It's a system response. Don't think it's a signal. I'm not talking about signal. I'm talking about system response, yt, system impulse response. Okay, that means input output relation. So with respect to time, this is the output. So as time is increasing, yt is also increasing. At t is equal to 1, output yt is equal to 1. T is equal to 2, output 2. T is equal to 3, output 3. T is equal to infinity, output is equal to infinity. What is the area under the curve? Area under the curve is going to infinite as time is increasing. Very important concept. So for another system, if it is found that yt is equal to t, yt is equal to t means if you are giving more time, the system output is growing or expanding. So I have shown you two kinds of sinusoidal signals. That is two kinds of damped sinusoidal. One is e raised to minus bt sine t, another is e raised to at sine t. Whenever it was e raised to minus bt sine t, it was oscillating and it was getting smaller. And whenever it was e raised to at sine t, it was starting small and it was getting bigger. Okay. So whenever it is e raised to minus bt sine t, signal was getting smaller. That means bounded. So it was a stable response. But whenever it was e raised to at into sine t, so as a is increasing, as t is increasing, as it is e raised to at, the sinusoidal waveform also was increasing. So that was a unbounded response. So e raised to minus bt sine at is a stable system. E raised to at sine bt is a unstable system. Same here, yt is equal to t. As time is increasing, output is increasing, increasing, increasing. In that case, this system, area under the curve, this is infinite. You cannot measure it because the area is always increasing. Okay, so curve looks like as shown in the left. Okay, we find that the area under the curve is increasing with respect to time. So as time is increasing, area under the curve is increasing, and the area under the curve actually gives us energy. So this is a system where energy is infinite. And what is the relationship between energy and stability? Inversely proportional. So if energy is growing, 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 what happens to stability? It is reducing very fast. So again, I'm telling you, this is the area under the curve is directly proportional to the energy produced by that system response. And as energy is growing with respect to time means system stability is increasing because energy and stability, they are inversely proportional to each other. So we find that the area under the curve is increasing with respect to time. The area under the curve is infinite and hence the curve of impulse response for a system given by yt is equal to t is called as a unstable system. So yt is equal to t, that means ys equal to 1 by s square. 1 by s square, if you take inverse Laplace, that gives you the value as t. So yt is equal to t is called as an unstable system. Previously we found yt is equal to 1 by s plus 5 or e raised to minus 5t. Yt is equal to e raised to minus 5t. That was a stable system. But yt is equal to t, that is a ramp kind of a response. This is actually a unstable system. So this system, because area under the curve is increasing ever with respect to time. So now some analysis I have given, that is response yt is equal to e raised to minus 5t gives bounded output. Bounded means energy under the curve is finite, system is stable. Response yt is equal to t, or some system might be having yt is equal to t square. It's a parabolic kind of increasing waveform. Okay, so we know how to plot these graphs because in experiment number 2 we know how to plot it. So a system impulse response now yt is equal to t square or yt is equal to t. Both are growing with respect to time. Both are unbounded output for other systems. Unbounded means the area under the curve is not finite. Okay, unbounded means the area under the curve is not finite. It keeps on increasing with respect to time. The system is called as unstable. So whenever you are finding that the area under the curve is, so you can find here. Okay, so another example is given. CLTF has Ts equal to 1 by s minus 3. Okay, so closed loop transfer function Ts equal to 1 by s minus 3. This is equal to ys. So ys equal to 1 by s minus 3. Where is the pole? So s minus 3 is equal to 0 is the characteristic equation. S minus 3 is equal to 0 is the characteristic equation. So s is equal to plus 3. So that's what I have shown. This is the s domain, and here I have shown this is plus 3. So here the pole is in the right hand side of s plane, and what we say is pole in the left hand side of s plane, system is stable. Pole in the right hand side of s plane, system is unstable. Why? This is the question. Answer is very simple. Do it in the time domain. So ys is equal to 1 by s minus 3, s is equal to 3. Find out what is the time domain response. So y is equal to 1 by s minus 3 means yt is equal to e raised to 3t. Yt is equal to e raised to 3t. So just pole is in the right side means what? Y is equal to 1 by s minus 3. Find the time domain response. That means just take its inverse Laplace transform. So if you're taking that, yt is equal to e raised to 3t. Yt is equal to e raised to 3t means this is a curve. So substitute t is equal to 0, it will start from 1. This is another thing you should be careful. That is y is equal to 3t. T starts from t is equal to, amplitude starts from amplitude 1, because at t is equal to 0, e raised to 0 is equal to 1. Many of you draw it from 0. Exponential curve does not come to 0. At t is equal to 0, it is e raised to 0 is equal to 1. So it starts from e is equal to 0 is equal to 1, and it goes and increasing. So how much is the area under the curve? Area under the curve, you are finding it is becoming infinite. So e raised to t is equal to infinite. Is it asymptotic? No, it is not asymptotic. E raised to minus 3t would have been asymptotic, but e raised to plus 3t is not asymptotic. It is increasing. It is not coming closer to t is equal to yt is equal to 0, but it is increasing and increasing and increasing. So there is a yt graph. I'm sorry I did not mention it. So this is yt graph is e raised to 3t. It is increasing. Area under the curve, area under the curve is increasing. As area under the curve is increasing, this is the time domain response. Yt is equal to e raised to 3t has area under the curve as infinite, because the area is increasing, and hence the area is unbounded. What is the input? Input is impulse, because ys is equal to ts equal to 1 by s minus 3. This was ts equal to ys by xs. Xs is equal to 1. So ys is equal to ts equal to 1 by s minus 3. That means input is impulse, bounded input. But what output I am finding? Output is unbounded. That is e raised to 3t. Hence, as the output is unbounded for a bounded input, and as the output is increasing with time, the system is unstable because area under the curve is ever increasing. Okay, so this is a very important page, what I have written. Some more things can be found out here. Okay, so it is given here. So is it understood? Anybody, can you just respond? That is bounded, unbounded,
Yes, sir.
stable, unstable. uh, Anybody else? So it is okay, right? I have taken very simple example. So if you're finding poles are in the right side, take the impulse response, and you will be finding that area under the curve is it is increasing with respect to time. That means it should be increasing kind of a thing. Okay, so graph should be increasing kind of a thing. If it is converging towards yt is equal to 0, or if it is coming closer to the x-axis, that means that is a energy signal. In that means again another definition of energy signal. What is the definition of energy signal? So it was there in signal systems. The signal which is coming closer to x-axis as time is passing. So a decreasing signal, okay, which is decreasing with respect to time. Hello, is it audible? Okay, so if a signal which is coming closer to x-axis as time is going by, then it is called as a bounded. Then the signal is called as an energy signal. Energy signal means it's having a finite energy. Power signal, I'll explain. Power signal is a little tricky. Okay, and the signal which is not coming closer to x-axis, that means a signal which is expanding like this. This is a unbound signal, and this is not an energy signal. Remember, this signal e raised to 3t is not an energy signal, but e raised to minus 3t is a energy signal. If this was signal, but I'm talking about now system. Okay, so this is the third page that I have written. Every page is very important. Now let us see. So now we know what is stable system. So if the roots are in the left hand side, is a stable system. The roots can be imaginary. It doesn't matter. Okay, the roots can be here, minus 2 plus 3j, minus 2 minus 3j. Doesn't matter whether it is on y-axis or x-axis, but roots are in the left hand side of j omega axis. Okay, left hand side of j omega axis is this whole thing. It can be real root, it can be imaginary root, everything. So all these roots are producing a stable system. All these roots which are in the right side of j omega axis will produce a unstable system. Okay, now the question is, what is the boundary condition? If ys is equal to ts equal to 1 by s, possible. Okay, so ys is equal to ts equal to 1 by s, but in that case, what is yt? So take the inverse Laplace of 1 by s, it is ut. So yt is equal to ut. What is the system response? System response is like this. Okay, so there's a unit step function. whether the system is stable or unstable. We call it system is marginally stable, and this is not an energy signal. Okay, ut is called as a power signal, and this ut is having power of half, so it's having a finite power. Okay, and what is energy? Energy is equal to power into time. So if it's having a finite power, in that case we can also say that system is neither it is not stable not unstable, but what we are calling is, it is called as marginally stable. So these are the three cases which are possible. We will discuss this thing in detail afterwards also, and this is the basis of whole control system. So analog control system basis is this, to understand what is the relationship between energy and stability. Okay, so if the response, impulse response, is having finite area under the curve, that means it's a energy system. In that case, the system is going to be called as stable. If the impulse response is ever increasing, in that case, the area under the curve is infinite. In that case, the system will be called as unstable system. Pole is in the right side. Pole is in the left side means system is stable because the area under the curve will be finite. If the pole is on j omega axis, so this is called 1 by s. So 1 by s means where is the pole position? So s is equal to 0. 1 by s, what is the characteristic equation? Characteristic equation is equal to s is equal to 0. That means 1 by s is actually an integrator. So integrator is a marginally stable system or a critically stable system. So 1 by s is the transfer function, that is equal to ys, that is the impulse response. That is ys by x is equal to 1 by s, or ys equal to 1 by s. What is yt? Ut. Ut looks like this, unit step function. Area under the curve, I cannot comment. Okay, this is not finite nor infinite, so this is a special case. It's a power signal, the power is equal to half. In signals and systems, you might have seen that. And what about stability? The system is neither stable nor unstable. The system is called as critically stable. So this j omega axis is actually the border. Left hand side is stable, right side is unstable, and on j omega axis, if any pole is there, so even if you are having two poles here, okay, plus j omega minus j omega, or plus 2 j omega minus 2 j omega, because complex poles cannot be alone. Complex pole always happens in conjugate. So if there is a plus 2 j omega, there will be a minus 2 j omega. So if poles are on plus 2 j omega and minus 2 j omega, what is its time domain response? It will be a sinusoidal of 2 radian per second. So if there is a pole here, plus 2 j omega and minus 2 j omega, that means what is the transfer function? 1 by s plus 2 j omega into 1 by s minus 2 j omega. That means s square plus 4. So 1 by s square plus 4, this will be a sinusoidal waveform. And that is called as a sustained oscillation with amplitude of something. So pole on j omega axis gives marginally or critically stable system. Okay. So LHS poles are stable poles and RHS poles are unstable poles. And the explanation for stability it gives with respect to the impulse response, but the criteria is applicable for all types of inputs. So not only impulse response, but for transfer function, actually we are trying to find out what is the pole, and we find that impulse response is equal to transfer function, that is ys is equal to ts. So this is the significance of transfer function that we are finding since the starting of this course. Always we are talking about transfer function, finding transfer function of electrical system, mechanical system, then finding transfer function by block reduction technique, then find transfer function by signal flow graph. But after finding transfer function, we do what? We do two things. First, we try to find out what is the impulse response. So Ts is equal to Ys, and from there we find what is the time domain response. So we find Yt, and from Yt we check whether the Yt is forming a bounded area with respect to x-axis, y-axis or not. If it is finding a bounded area, then we call it a stable system. We find how much is the area under the curve. Area under the curve is equal to joule, that is produced by the, that is the energy produced by the system. Okay, so that is called as impulse response. And from the impulse response and from the characteristic equation of the transfer function, we try to find out whether the system is stable or unstable through the position of poles. So we solve for the denominator equation. If you are finding denominator equation is having all poles in the left hand side, we call the system is stable. Because poles in the left hand side means it will produce a asymptotic kind of a curve in the time domain, and asymptotic curve is having a bounded energy, bounded area, bounded energy, bounded area means system is stable. So this is what is the whole story about. Then there are three cases of stability. Poles in the left hand side of S plane, let it be real pole, let it be imaginary pole, doesn't matter. poles in the left hand side of j omega axis, system is going to have a reducing kind of response in time domain, which is called as a stable response. Poles in the right hand side of S plane, let be real pole, let be imaginary pole, it will be having an increasing kind of a time domain response. Then area under the curve is infinite, we call it unstable system. In the last case, which is shown here in this page, that is if the pole is on j omega axis. So there can be many pole on j omega axis. Okay, so here it is S 1 by S, that means yt is equal to ut. So this is a special case. This is neither stable nor unstable. This is called as a marginally stable or critically stable system. We don't design a critically stable system. Example, suppose my salary is 10,000 rupees per month and my expense is 10,000 rupees per month. Okay, in that case, I cannot do little here and there. If I do little here and there, then again I will be getting some loans in the market, udhari. Okay, so I want to live life without any kind of loan, but my earning is also 10,000 and my expenditure is also exactly 10,000 per month. So I do here and there little bit and I become unstable, I get some loan. But if my salary is 10,000 and my expenditure is 7,000, that means that is the 3,000 rupees cushion I'm having in my hand. So in that case the system is stable. Okay, so stability means your pole should be towards the left hand side. And deeper, if I say there are two system poles, one is at -3, another is at -7, who is more stable? Obviously the pole who is at -7, that will be more stable. So if the system pole is too much deep into minus infinity, system is most stable. Okay, and as you are coming closer to this j omega axis, system stability reduces. Again, I'll repeat very important thing. Pole is there at -7 and pole is there at -3. Who is more stable? Obviously -7 is more stable, because e raised to -7t and e raised to -3t, these two plots you do, which plot is having less area under the curve? Obviously e raised to -70 will be falling faster. That means the area under the curve e raised to -70 will be lesser compared to e raised to -3t, because e raised to -3t will be kind of a flat and a lot later it will touch the zero axis. So area under the curve जिसका जितना कम है उसका stability उतना ज्यादा है. So e raised to -70, which is too much deep into j omega axis, and e raised to -3t, which is little closer to j omega axis. So both are stable. Okay, both are having finite area under the curve, but e raised to -70 will be having lesser area. Hence, e raised to -70 will be called as a more stable compared to e raised to -3t. So when two systems, both the systems are stable, then there comes a concept of relative stability. So -3 and -7, two poles are there. Who is relatively more stable? Answer is e raised to -70, or pole -7. It is more stable compared to -3. So the rule is, if you are deep into j omega axis, you are highly stable. As the pole is coming closer to j omega axis, the pole is coming closer to instability. And the pole is on j omega axis, it is called as critically stable or marginally stable. And again, you are crossing this and going into the right side of S plane, you are becoming unstable, or the pole is becoming unstable. So pole is at +2 and pole is at +6. Who is more unstable? Obviously the pole which is at +6, this is more unstable compared to the pole which is at S is equal to 2. Likewise, so from left to right, instability increases. From right to left, the stability increases. This is the maha mantra of a control system in the Laplace domain for continuous systems. From left to right, if you are coming, the instability increases or instability increases. From right to left, if you are going, the system stability increases. What is meant by system stability? Area under the curve will be less and less. Okay, so deep into S plane, e raised to -70, area under the curve will be very less. A little bit closer to j omega axis pole, e raised to -2t. In that case, the area under the curve will be more. That means system is having more energy. System is having more energy means system is having little less stability. So this is the whole story of stability, and this understanding, if you can remember throughout your life, it will be helping you. And not only in control system, every field of study, you have to correlate energy with stability. So more is the energy, less is the stability, because that is the maha mantra of control system. Stability is inversely proportional to energy. Gain is directly proportional to energy, and gain is inversely proportional to stability. So these are the three things I told you long back, and I'll stick to it. Now the last topic, a half a page pending. What is meant by uh, impulse response we have seen. Now let us see what is meant by step response. Okay, so only this transfer function will change. My question will remain same. So I will give, this is a first order system. I can give you a complex system and I can ask you find what is the step response. Okay, so this is the same numerical which you have to follow. Only thing, this transfer function will change. So your calculation will increase, but step will remain same. So Ts equal to Ys by Xs, Ys is equal to Xs into transfer function. In case of impulse response, we substituted Xs is equal to 1. So we found Ys is equal to Ts and we found Yt. How could I found Yt? Yt is the inverse Laplace transform, there is a ILT of Ys. So Yt is equal to e raised to minus 5t. So for this given GS, for this given HS, the e raised to minus 5t was the impulse response. Now I'm asking you for the same system, how much is the step response? So y is equal to xs into 1 by s plus 5. Now ut is the step input, unit step input. This input if you are giving to the system, who is having transfer function as 1 by s plus 5, then what is going to be the system step response? That is what we are supposed to find out. So ut is equal to Laplace transform of 1 by s. Okay, so substitute this xs as 1 by s. So t is equal to ys by xs, y is equal to xs into 1 by s plus 5. Now you give input as unit step. Generally we give input as sinusoidal to any system. Okay, but for finding the time domain response, okay, step response, we are actually giving the unit step input. So xs I have substituted as 1 by s. Now y is equal to 1 by s into 1 by s plus 5. Now you have to do what is called as partial fraction. So a by s plus 5 plus b by s plus 5. I have shown you how to find the partial fraction, coefficient a and b, how to find out. So a you have found out as 1 by 5, b we have found out as minus 1 by 5. So y is equal to 1 by 5 into 1 by s minus 1 by s plus 5. So what we have found out is yt is equal to 1 by 5, 1 minus e raised to minus 5t. This is actually same as how the capacitor charges. So this is the x-axis, y-axis. This is the unit step input. So it will start like this and it will go and saturate there. So increasing kind of a graph which is there. So we'll plot it very shortly. This is actually the step response. So don't go on finding stability here, because we are not talking about stability. Stability we are talking about in impulse response. Here I have given the step input, that is this unit step input. So if this is the x-axis, y-axis is the unit step input, then what is going to be the system output if the system is equal to 1 by s plus 5. So what is the step? Y is equal to xs into 1 by s plus 5 transfer function. Substitute x is equal to 1 by s. So now 1 by s into 1 by s plus 5. This is the case. We are supposed to find out yt. So to find yt, first you have to find the partial fraction. So a by s plus b by s plus 5. This is how the partial fraction is done. Y is equal to 1 by 5 into 1 by s minus 1 by s plus 5. Take the inverse Laplace transform. So 1 by s inverse Laplace is 1 and 1 by s plus 5 e raised to minus 5t. So yt is equal to 1 by 5 into 1 minus e raised to minus 5t. And how the graph looks like, it will start from the 0 and it will go on increasing and it will go on saturating after a certain time. Okay, that is 1 by 5 into 1 minus e raised to minus 5t. This is called as the step response of the given system. Okay, so now if there is any doubt, I'm asking, please let me know, or we will go to the MATLAB.